Hey Red Devil Chemist, how you doing? It's Coach Scott with another edition of Let's Work the Problem. Working on Worksheet 4, let's look at problem 19. Alright, so let's look at it so we can get this one over with. Barium chloride is found as a hydrated salt. Alright, BaCl2, so many waters. Okay, a student carefully heats up 2.5 grams of the salt to a constant mass of 2.13 grams. This should be pretty easy, guys. So let's look and see what we got. We've got a 2.5 gram sample, 2.50 gram sample. Okay, and let's think about what's in that sample. That's the barium chloride, and it's also the water, BaCl2 and XH2O. H2O. All right. So we're going to heat it up, and when we heat it up, we're going to drive off all those H2Os because we're heating it strong. All right. So then we go and get that into a constant mass of 2.15 grams. And let's think about what that is. That's just the barium chloride because we drove off all the water. We drove it off. All right. It has changed color. It's done something different. The water is gone. And now we just have the salt. So all that's left is the barium chloride. So now if I subtract 2.15 from 2.5, I get a mass of 0.35 grams. And let's think about what that is. That's the water that was in the salt, right? So now I've got the total mass. I've got the mass of the barium chloride that's part of the total, and then I've got the mass of the water. So now, as anything, if we have mass in any of the stoichiometry problems, what do we got to do? Got to get it into moles. So let's start with the barium chloride. I like green today. 2.15 grams of BaCl2. Let me move the thing down a little bit. Of BaCl2. All right. And to get that into moles, I've got to get the atomic mass. Mole. BaCl2. Using my my wonderful periodic table, barium has a mass of 137.33. And it has 2 chlorines, so that's plus 2 times 35.453. That means it has a mass, a formula mass of 208 grams, 208.236 grams. All right, BaCl2. So how about I take 2.15 and I divide by 208.236 grams, I get, and I'm going to use scientific notation, 1.032 times 10 to the minus 2 moles of barium chloride. Okay, so let's do the water. So I have 0.35 grams, 0.35 grams water. Convert that into moles. 1 mole water, H2O. All right, that's 1.0079 times 2 because I have 2 hydrogens, plus 16 for 1 oxygen. I get 18.0158 grams. 18.0158 grams of water in 1 mole. So if I divide 0.35 divided by 18.0158, I get 1.942 times 10 to the minus 2 moles. So these are relatively small. So let's do this. Let's take our BaCl2 H2O, and we can put these moles in there, and we're trying to get a whole number, 0.942 times 10 to the minus 2, then 1.032 times 10 to the minus 2. And we see that this is much smaller than that one, and if we divide everything through by that, all right, if we divide this through by itself, 1.032 times 10 to the minus 2, that's going to be a 1. And if we take 1.942 and divide it by times 10 to the minus 2, divide it by 1.02 times 10 to the minus 2, divide it by each other, I get a 1.9, which is essentially 2. Alright, so that means the formula for barium chloride hydrated salt is going to be BaCl2 with 2 waters. So that would be barium chloride dihydrogen. Barium chloride dihydrogen. Solved. Problem is solved. Problem is solved. Let's see, can we get into 20? No, let's wait on 20 a little bit. I'll do it by itself. So guys, this is Coach Scott saying, Red Devil Chemist, peace out.